Okay folks, we're looking at tree diagrams today, particularly for probability problems. So, fairly standard type question to show you how to work it. There's a silly game being played where they're going to take a ball out of this bag where there's a mixture of red, blue and black. I hope you can tell there's only blue and black on this screen. And here we've got a mixture of red, blue and black. So it's one ball from bag G and then one ball from bag H. There's no blues in there, so these are the only blues. These three here are blue. Red and black, red, blue and black in there. And it says we're going to use a tree diagram to find the probability of some stuff. We'll get to what we're actually going to find later on. So I'm going to set up our diagram first before we think about how to use it. So we need to be clear here, there's an event and an outcome. An event here is taking a ball from a bag, and the outcome is whatever colour it happens to be when we look at it. So the first event is to take a ball from bag G. When we do that, there are three different outcomes that might happen. So in the diagram, that means we have our first event goes from somewhere here, and there are three outcomes which we're going to spread out like that. So there could be that outcome, or that outcome. So this is bag G, this is the first event, splits our world from everything being the same to three different outcomes. And these outcomes are red, blue and black. And then our second event is taking a ball out of bag H. And here there are only two colours, so that means this gets split into two possible worlds, one there and one there. This gets similarly split, one there and one there. And this gets split into two worlds as well, one there and one there. And this is going to be red and black. This is red and black. This is red and black. So, whenever you play this game of taking a ball out of this bag then this bag, we actually are following a path along this thing. So we start here, we take the first ball out, it might be black, and the second ball might be red, and we end up here. If we do black then red, we just follow the branches. If we end up here, we must have done blue then red. Each of these branches has a probability of occurring. We can do that using our basic probability by counting stuff here. So there are 1, 2, 3, 4, 5, 6, 7 red balls in there out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7/12 of those balls are red. 3/12 of these are blue and 2/12 are black. It may be useful to simplify these fractions down, not always, but that simplifies to 1/4 and that simplifies to 1/6. So hopefully you can read there the probabilities of each of these three branches happening. These branches are just this bag where there are 4 reds out of 10, I hope. Yes, 10. That's 4/10, that's 6/10. And because the bag is the same every time, these will be the same. There are questions where these numbers are different because what happens first might change what's in the second bag. For example, if they took the ball out of here and put it in here, that might change what these could be. But that's a more complicated question for a later day. And again, these simplify, so that's going to be 2/5, 3/5, 2/5, 3/5, 2/5 and 3/5. So this is now set up. I'm sorry it's got a bit scrappy there, but that is all set up. So now we look at our actual question. The first question is a red followed by a black. That's a dark black B there for black. Hopefully using blue and black both starting with B. But so, a red then black is this path here. So that means this has got something to do with 7/12 to get to red. And then from there it's got something to do with 3/5. Now our last video was about the and all rules. So red and then black. Nice big emphasis on red and then black. Your and rule tells you I should be choosing to do what with these numbers? Multiplying. So 7/12 times 3/5. There are a few different ways to do that, including typing on a calculator, but I think we get 7/20 when that's all simplified down. So that means the answer to this question over here is 7/20. So that's the first question. We took our root, which was started here, followed it through and multiplied along the branches to get that. Multiplied along branches to get that. Happy, so easy so far. Now this is a bit trickier, getting one red ball. Now there are lots of ways to do that. I like to tick them as I go. I'm going to start using green to stand out a bit. So this is one red ball. Red then red is 2, that doesn't count. Blue then red is one red ball. Blue then black hasn't got any. Black then red has one red ball, and black then black doesn't have any. So there are these 3 branches. I've already worked this one out as 7/20 by multiplying. Similarly here, we're going to multiply 1/4 times 2/5 is 1/10. And here we've got 1/6 times 2/5, which is 1/15. But we could have this option, or this option, or this option. And you did the OR rule in the same previous video, so we know that OR is addition. So that means that this over here is these 3 added together. So that is 7/20 plus 1/10 plus 1/15. And on a calculator paper or question, this is easy, it's just typing. If you didn't simplify these down, this would also be a bit easier because they'd all be out of 120 now. But these do all come out of 60, so that's going to be 21/60 plus 6/60 plus 4/60, which I think makes altogether 31/60. But the actual fraction calculation isn't really meant to be the challenging bit of this topic, so you can just type those into a calculator. When you're ready for your GCSEs in a few years, this should also be easy to do, as well as the calculation, as well as the choosing the right thing to do. Okay, finally, both balls are the same colour. Well, that could be red then red. So that could be this one. That's red red. This one red then red, and this one black then black. So there's just 2 things here. That top branch is 7/12 times 2/5, and this bottom branch is 1/6 times 3/5. And I'm adding these 2 things together because of the OR rule. It's the top root or the bottom root, and each root has a multiplication in. So it's this and this, or this and this. It's a complicated thing to say out loud, but there you go. We work this all out and we get some number of 30ths, I reckon. 7/30 plus 3/30, which makes 10/30, which is 1/3. So 1/3 of the time we do this operation with this setup, we take a ball out of each bag. 1/3 of the time we are going to get 2 balls of the same colour. The principles you need to take from this are every time you do a thing, do an event, you need to split up into the outcomes that could possibly happen, and you need to split and split and split again until at the end you've got all the outcomes. The output you get by multiplying along the branch, and any branches you care about can be added together to make a total. I hope that helps.